Yes, and I'm going to be presenting the project for week number 7 for the class Advanced Structural Mechanics, where we're going to have to prove by hand or any other method the formation of the areas and volumes of the figures that we have been working on since the beginning of this class. The project tasks are going to review the MATLAB codes that have been provided by our professor, define a surface in our body and a volume in our body, and we also are going to verify by hand the deformed area using this equation over here, and we're also going to verify by hand the deformed volume with this equation right here. As we have working on this from weeks before, we already have defined the map of our figure. We computed the deformation gradient, the parameterization of our body, and the tangent vectors. We have 2 cylinders and 2 cones, and that's why I only did it once. So for this project, once you run the program, you're going to get the undeformed and deformed areas of the areas of the surface, the volume, and the lengths. For this project, we only have to work on the areas of the surface and the volume of the body. I decided to choose surface area of the volume part 1, which is cylinder. It's my first cylinder, and we're going to prove that this value they match. So the first part we're going to verify by hand is the area of the surface. Once we do that of the undeformed area, it's going to be pi that multiplies 2 times the radius square, which is going to be equal to 28.27. We're going to have the deformation map. We are going to do the parameterization of the deformed surface. It's this one right here. Then we're going to do the area Jacobian of the deformed surface. And lastly, using the formula given by a professor, we're going to the deformed area, and we got 38.85. Next, we're going to verify by hand the volume. The undeformed volume is going to be pi to r square times the length, which is 1, so it's going to be 28.27, the same value as before. Then we're going to do the deformation map, and then we're going to do the parameterization of the deformed body, and after that we're going to get this new value and plot it in our equation to find the deformed volume, which we got 46.12. As you can see over here, those values match. Lastly, I want to show that the program run works. When I run my program, you're going to get the deformed length of all the curves, and then you're going to get the figures of 2 cones and 2 cylinders trying to imitate hourglass. And that's all I have for this video. Thank you so much for listening, and see you next week.